Using heat. How do modern appliances use heat or the absence of heat? You know, most modern homes have what's called a central heating system. How it heats a house is, well, pretty straightforward. A central heating system has a furnace, and here we have a very crude example of what goes on inside a house, but we have something called a furnace here. Now these furnaces, when you think of the word furnace, you think of a big open fire pit. But in modern day world, you often have something along the lines of this, where it's very much electrically operated. You don't see a big fire pit like you might would see here in this cutout of what a furnace would look like. But even this cutout, you have a motor which kind of provokes with a combustion chamber in there. But anyway, however it is, whether it's by coal or oil or electricity, the heat moves from the furnace through insulated pipes. The heat is produced in here. The combustion, in some cases, is produced in here, and you have these insulated pipes, and it goes through these insulated pipes, and in some cases to things called radiators. In some cases, it just goes through the duct work. And anyway, it's just a basic transfer of heat. This heat goes from here into the rooms. And of course it's by convection because it goes through a gas. But that's pretty straightforward. You make the heat and the heat goes out and makes things warmer. As after this transfer of heat, the same amount of energy has to be present. You may remember the law of conservation of energy. And it said that energy cannot be created or destroyed. It's only put in different forms. So you have this heat which is created through electricity. You have ions which are going through the wires, and it ends up going out into the house. Now, once it comes out the vents, then it's not very usable, and it's there. It's just that we can't use that energy for the same type thing, even though the energy is still there. So it's unusable, you might say. Central heating systems are far from 100% efficient. You will lose heat to the pipes themselves. The pipes themselves could get rather warm. You will lose heat out the walls. I mean, if you were to stand outside and put your hand on the walls, there is some degree of heat which could come from there. Lots of different places in which you could lose heat in the central heating system. It is good to have insulation to help keep some of the heat from being lost. Now, I did not get pictures of insulation, but you can have insulation on walls. You can have insulation in the roof. And what that insulation does is keep it a little more efficient, which means the heat which comes out into the rooms isn't lost as easily out through the top of the roof or out through the walls and out through doors and things such as that. It doesn't make it 100% efficient, but of course it's a little bit better. So that was pretty straightforward. But what about cooling things? You may remember that heat is transferred, not cold. You may remember the example where we had the hand and the ice cube. Sure, when the ice cube is melting, your hand feels cold, but it's not from a transfer of cold. It's because your hand is having the loss of heat. The only thing that is transferred, of course, is going to be heat. You don't transfer cold, but you feel cold. And the reason you feel cold, like I said, is because of the absence of heat. You have two different temperatures, warm with the hand, cold with this. And even though you can't transfer the cold to the hand, you still can use this same type setup. You can use this same type setup to put the cold where you want it. And that's exactly what happens in something like a refrigerator. This is a refrigerator. You can see the refrigerator handles here, the freezer part up top and the refrigerator part down at the bottom. That's exactly what's happening here. The cold is produced even though it wasn't transferred. The cold is what was left after on the hand. So in this refrigerator, near the rear or near the base, you will have heat coming out. Just like what you have up here, you have heat coming out of the hand. You have heat coming out of the hand, and what is left is going to be cold on the hand. So similar premise. Heat comes out the back of the refrigerator. Now, the reason you can have the heat coming out, well, first of all, you have the compression pump and the motor, but it's not just a matter of pushing heat through. You have to have something called a refrigerant. And I didn't write that down because it sounds so much like refrigerator. But you have to have something called a refrigerant to really make it cold. A common refrigerant is called Freon. And to understand what Freon does in these pipes right here, you have to understand what happens when you have a change of state. Now the states are going to be solid, liquid, and gas. And when you have a change of state, you have excess energy. You see you have energy output going this way. So the farther this way you go, the more energy you have. And in this case, it's going to be heat energy. So when you change from a solid to a liquid, when something melts, you have to have excess heat. When something evaporizes, and I don't know why they put vaporization here, it must be some kind of British pronunciation. But anyway, whenever you have liquid going to gas, you have evaporation. And that evaporation is going to have extra heat that is produced. And that's exactly what's happening here. You may have noticed we have some coils, what's called an evaporator. The Freon inside the coils evaporates. It evaporates into a gas, and it uses up the energy, it produces the heat, and then it condenses at the top here. And then it goes back down and evaporates up again. So you constantly have all these changes of state, changes from, in this case, liquid to a gas, and it's producing this heat. The reason it's producing this heat is because it's kind of like the hand here. You have the heat which is escaping. The heat which is escaping into these coils. The heat here is escaping into the ice cube, makes it warmer. So what is left is cold hand. Here you have the heat that is escaping into these coils. What is left? Cold refrigerator. So it's just a matter of producing one thing that is hot, one thing that is cold, and getting the heat out of what was once hot. And that makes it cold. Does that make sense? Well, I hope it does. Air conditioning homes uses the same process. So let's use this. Notice what we have here. We have the outside of the home here. Why don't I use a different color? We have the outside of the home here. We have the inside of the home here. Look at these evaporation tubes. You have the same type thing. Some kind of liquid like Freon is going to be evaporated in here, and it's going to cause the different change of state. And because of that, you're going to end up with the cooler air. So what we have here, we have a fan next to these. It blows the air this way, and the fan is going to end up blowing it through the ducts. Let me read exactly what I have. Air conditioning homes uses the same process. You have evaporation coils, like you see here, that cool because of the heat transfer. And then a fan would then blow the air through the ducts. So that's exactly what you have. Now you do have something called a heat pump, which kind of serves the same function as a heater and a air conditioning system. And what it does is, I'm not even going to have a diagram on it. It pumps the refrigerant in an opposite direction to go with heat. So just realize it is the same process. It's just a matter of whether you want the refrigerant blowing in or whether you want the heat blowing in and the cool, I guess you would say, blowing out. But it still uses the evaporation and condensation and the heat from that to have the effect of that absence of heat, kind of like you did with the ice here. It's that absence of heat which makes this hand colder, and the absence of heat which makes the refrigerator and which makes the house cooler. Don't forget to go back and look at the questions. Hey, I hope you've learned a little bit here.